At this point, we have two methods for solving two linear equations in two variables. The first method that we examined was graphing. If I have two linear equations in two variables, and I can construct the graph of the two lines, either using intercepts or the slope-intercept form, and identify the intersection point of those two lines as an ordered pair, then I've found the solution to the system. We did one example of this at the end of section 1.3. In section 1.4, we learned an algebraic method for solving systems. This is called elimination. The process is different. We're manipulating the equations to find the ordered pair solution without ever looking at a graph. We're going to consider a new method in section 1.4.2. Two equations in two variables using matrices. I think you'll like this method because we're going to be using our calculator extensively, and it will be a fast and efficient method. You'll probably like it better than the algebraic elimination method. Before we get started with the method, we need a little bit of background information about what a matrix is. Technically, a matrix is defined as a rectangular array of numbers. That is a fancy way of saying it's a box of numbers or it's a table of numbers. A matrix has rows and columns. What we're going to do is use basically a table to express a system of two equations in two variables. For example, suppose that I have this system, two equations in two variables, and I want to rewrite it in the form of what's called an augmented matrix. In an augmented matrix, we're going to start with a square bracket to open up our matrix. This matrix is going to have three columns. In column 1, we're going to record the coefficients of x in each equation. In column 2, we're going to record the coefficients of y in each equation. Then our augmented matrix is going to have a vertical bar, and on the other side of the vertical bar, we'll have a constant. So let's translate equation 1 into matrix form. Equation number 1 is 2x plus 3y equals 7. I'm going to observe that the coefficient of x is 2 and the coefficient of y is 3. The vertical bar in the augmented matrix represents the equals of the system. On the other side of the equals in equation 1, we have the number 7. So row 1, 2, 3, 7 corresponds to the equation 2x plus 3y equals 7. Now, having understood that, can you figure out the values for row 2 of the matrix? You should get 3, -4, and -32. This is what we call an augmented matrix. Let me take just a minute to point out some important parts of the matrix. First of all, just so that we get our vocabulary correct, remember that rows are horizontal. They go across. And columns are vertical. They go up and down. In the left side of our matrix, we've recorded all of the coefficients of the system, so we call this part the coefficient matrix. Understanding that the vertical bar represents the equals, on the other side of the vertical bar we have a column which is called the augment. Those are the parts of an augmented matrix, and it's just a tabular way of expressing a system of, in this case, two equations in two variables. We're going to manipulate the matrix with our calculator to solve the system. Now, the first thing that we're going to have to do when we enter this matrix into our calculator is indicate the size of the matrix. So the size of a matrix is always given as the number of rows first by the number of columns. So in this case, our example matrix has 2 horizontal rows and 3 vertical columns. So we would say that this is a 2 by 3 augmented matrix. It's pretty simple. If you've ever used Excel, the spreadsheet, or if you've used Google Sheets to record data, you've got rows and columns. Each row represents something significant. Each column represents something significant. That's an example of a matrix. We're just using that tabular method to express our system. Now, to solve our system, we're going to use something called the Gauss-Jordan method. This is a calculator technique that we're going to use. It uses row operations to transform a matrix into reduced row echelon form with ones in the diagonal, that's the word ones in the diagonal, and zeros above and below the diagonal ones. Now, we're going to learn how to solve this with our calculator, but we do need to know how to interpret the solution. So let me show you what a reduced row echelon form matrix looks like. Now, remember, we're going to start with an augmented matrix that represents a system. We're going to enter the augmented matrix into our calculator, and the calculator is going to do similar operations that we did when we learned the elimination method. Remember how we got opposite coefficients for x and we canceled out one of the variables? That's essentially what your calculator is going to do. That's what we mean by row operations. Once the calculator reduces the matrix, it's going to end up looking something like this. So we have ones along the main diagonal, we have zeros above and below the ones, and then we just have constants in the augment. Now remember, column 1 represented coefficients of x, column 2 represented coefficients of y, the vertical bar is the equals, and the numbers over here in the augment, those were the constants of the system. So when I see that diagonal of ones, it is in reduced row echelon form. By the way, your calculator will refer to this as RREF. Once the matrix is in this RREF form, then we're going to translate it back into equation form, and you'll be able to discover what the answer is. Looking at row 1 and going from matrix form back to system form, row 1 would be the equation 1x plus 0y equals some number a. Now, we can simplify that. 1x is just x, 0y goes away, and we have the x value of the solution to the system. Translating row 2 back into equation form, we could write that 0x plus 1y equals b, or if we simplify that, y equals b. Thus, once we get our matrix into reduced row echelon form, we can see here that the augment displays the solution. Then we can proceed to write our solution as an ordered pair AB. So the process works something like this. We're going to start with an ordinary algebraic system, 2 equations and 2 variables, which represents 2 intersecting lines. We're going to rewrite it as an augmented matrix, and then we're going to type that into our calculator. The calculator then will reduce the matrix into RREF form, reduced row echelon form, and we'll be able to identify the solution by looking in the augment. Now, I'm going to take you through this calculator process step by step, but I do want to remind you at the bottom of your notes in this section, if you go to page 15, all of the steps that we're about to go through are recorded here in your notes. So you can refer to that, and you don't have to worry about writing down all of these steps. It's already written down for you. So let's practice solving a system using our calculator. The first step is to rewrite the system as an augmented matrix. So we're going to rewrite row 1, picking up coefficients, as 2, 3, and then our vertical bar and the constant is 7. Row 2 has coefficients 3, -4, and -32. That's our augmented matrix. Now we're going to enter this matrix into our calculator. So to get to our matrix menu, You notice above your X to the -1 button over there on the left side, you have the word matrix. So I'm going to type my second key and then my matrix button. Now, when you open up your matrix menu here, you may see numbers written there next to those letters. If so, don't worry about it. We're going to type right over it. Now, I'm going to come to this matrix menu 3 times over. The first time, I'm going to use my right arrow key to highlight Edit. Okay, and then press Enter. Then I'm going to enter the size of my augmented matrix. Notice this matrix has 2 rows and 3 columns. Whoops, 2, and then Enter, 3, Enter. So the calculator adjusts the matrix to have 2 rows and 3 columns. Again, if you have something there, you can type right over it. Now I'm going to take my time and plug in the entries from the matrix. So we have 2, 3. I'm just pressing Enter after each entry. Make sure here you use your negative button, not the minus operation. And my calculator is covering up the value there. That value should be -32 in that last spot. So I'm going to look over my matrix to make sure that I have everything typed in correctly. And once I know that it's typed in correctly, then I can quit back to my home screen. So I'm going to press second and then quit. Okay, now we've stored the matrix in our calculator. Next, we're going to tell our calculator to reduce it. So I'm going to go back to the matrix menu for the second time. Now I should be able to see that 2 by 3 listed there next to matrix A. And in the second time I enter this matrix menu, I'm going to highlight Math. So just use your right arrow key and highlight Math. Now there's a whole lot of matrix operations that are available here. We're going to go way down the list until we find RREF. Notice there's an REF there. That's row echelon form. We're not interested in that one because it's not unique. We are interested in double REF. So highlight option B, RREF, and press Enter. Okay, now we have to tell the calculator which matrix we want it to reduce. So we're going to go back to the matrix menu for the third time. Remember, first time around we chose Edit. Second time around we chose Math. Here, the third time around, Names is highlighted, and I'm just going to press Enter to pick up Matrix A. That's where I stored the information. Then we'll close parentheses and press Enter. And in just under a second, the calculator solves the system. So remember, we solve these algebraically using elimination. Here, the calculator does it very, very quickly. Notice over there in the augment, we have values -4 and 5. So let's go ahead and write down our reduced matrix. It had the 1s in the diagonal and values -4 and 5 over there in the augment. So now we can observe in the augment we have the solution to the system, and we will officially express our solution as an ordered pair. So the ordered pair solution xy then is -4 and 5. Okay, so what that means is the two lines represented by this system are going to intersect in quadrant 2 at the ordered pair -4, 5. It's a fast and efficient system. You can check this by plugging -4 and 5 in for x and y in the original equation, or just verifying that you've entered the values correctly into your calculator. Okay, so once you learn the process, it's really a piece of cake. So let's try another example. We'll go through the process one more time. So in this case, we begin by writing our matrix as an augmented matrix. Let me go ahead and do that first. I'm just picking up coefficients and putting the constants on the other side of the vertical bar. So row 2 will be 9, -8, and -24. Then I'm going to open up my calculator and I'm going to enter this into the matrix menu. So we're going to press our second button and then the matrix menu. I'm going to highlight Edit first time around, and you can name this whatever you want. I'm just going to show you. I'm going to type right over what I had there originally. So the new matrix that I'm entering is 2 by 3, and then I'm going to take my time here and plug in the entries. one by one. If I'm going to mess this up, it's going to be at this step right here. So we want to make sure we get our entries in correctly. Okay, and then take a minute to double check your values. Make sure you have all the signs. And once everything is entered correctly, then you second and quit back to the home screen. Okay, then we'll immediately return to that matrix menu. Second time around, we choose math. And remember, the double REF was way down at the bottom of the list. Well, if you're really in a hurry, you can use your up button and get there a little bit faster. Okay, it'll take you to the bottom of the list and you can get to RREF. Again, make sure you pick double REF, not single REF. Once that operation is on our home screen, we can do second matrix, go back to the matrix menu. I'm going to choose number 1A and close parentheses and press enter. So in the augment, in that last column, we see values 8, 12. So let's record our reduced row echelon form, and we have values 8, 12 in the augment. Therefore, we know that the ordered pair solution of this system is ordered pair 8, 12. So without even graphing these two lines, we know that they would intersect in quadrant 1. Our last example for this section has one little twist. I do want to point this out to you. Just as we did with elimination, when we're solving a system, it's really important that our original equations are in standard form. Remember, standard form is when we have x and y together on one side and the constant on the other. In this case, our two lines are not in standard form. So we're going to need to move both of these constants to the other side before we can plug it into our calculator. So let's rewrite the system as 6x minus 3y equals 4. Notice I obtained that by adding 4 to both sides. Let me get this off so that it's clear. And then we're going to add 7 to both sides, so that equation is 3x plus 6y equals 7. Now they're both in standard form, and I can go ahead and write down the augmented matrix form of this system. So just picking up coefficients, and then we will plug that into our calculator. So one more time, we're going to go through this process. Start with second matrix, highlight, edit, and this time I'll give you another option. If you want to save matrix A, we can plug this in for matrix B. So I've highlighted matrix B this time using my down arrow key, and I just have to remember the name of my matrix is B. The size of this matrix is 2 rows and 3 columns, and then carefully type in your entries, watching those signs. Okay, look over it, make sure everything is plugged in correctly, and then second quit back to the home screen. Okay, then immediately return to the matrix menu. Second time around, we choose math. I'm going to do the shortcut and arrow up to RREF from the bottom and press enter. And for the third time, go back to the matrix menu. Names is highlighted, and I have to remember I called this one matrix B. So I'm going to make sure and highlight B, press enter, close parentheses, and the calculator very quickly solves the system. Notice this one looks a little bit different because we did get a decimal result, but we're going to clear that up very quickly by pressing our math button. Remember, option number 1 is fraction, and we'll let the calculator convert it back to a fraction. So in the augment position, I have values 1 and 2/3. So I'm going to rewrite my reduced row echelon form. And then I can observe the ordered pair solution is x equals 1, y equals 2/3. This is a really fast and efficient method. Keep in mind, now that you know this method, if we backtrack to our elimination method, another option for checking your work, remember we checked these by substitution, now you can go and plug that into your calculator as an augmented matrix and verify that you have the right answer. So it's a great method all around. In the next video, we'll look at this same method but applied to larger systems.